How is this different than that?
Okay, so here's the definition of a power series. If x is a variable, if x is a variable, then an infinite series of the form a sub 0 plus a sub 1x plus a sub 2x squared plus a sub 3x cubed on up to a sub n x to the n, which in summation form looks like the sum from n equals 0 to infinity of a sub n. Sorry. Dadgummit. It's terrible.
Plus, we'll have to wait until tomorrow to finish it.
Got it. Maybe.
Oh, no.
Same.
Yeah.
Okay, a sub n.
Those are gold. I think it's fun password.
I don't know why it's doing that.
Alright.
A sub n x to the n is called a power series. An infinite series of the form a sub 0 plus a sub 1 x minus c plus a sub 2 x minus c squared plus a sub 3 x minus c cubed
What?
Okay, so what have I done here? What have I done in this one?
Added the center.
Yes, is a power series centered at x equals c. Okay, so are Taylor and Maclaurin polynomials power series? Yeah. Yes, they are, right? All that happened is when we wrote them in this general form, what's missing? Like the factorial in the denominator, but what's happened to it? It's just been divided out, right? In order to create this coefficient here. Yes.
Like that whole center thing, is that mainly used for like polar graph? Like how would you graph things?
It just is like where you start the graph. So like if you're coming up with a Taylor polynomial for sine of x at x equals 0, when you start your polynomial, it's going to start at 0 and it's going to build out from there. You could start it at pi halves if you want, and you would build it from there. It's just a starting point. Okay. All right. Okay, and then we'll put here Taylor and Maclaurin series are considered power series. Okay, so we're going to start with a little bit of review here. Write the first 4 terms and the general term of the Taylor series expansion of f of x about x equals 0 for f of x equals 1 over 1 minus x. Okay, so I'm supposed to write the first 4 terms and the general term of that Taylor series expansion, f of x equals 1 over 1 minus x. Okay, so how would you do that with the knowledge that you have right now? Okay, is it a manipulation of anything that we know?
No.
No. So we're going to have to do this the long way, right? Okay, so let's start. So f of x is equal to 1 over x minus 1, which is the same as
1 minus x to the negative.
Yeah, 1 minus x to the negative 1, right? Okay, it's centered at 0, right? So f of 0 is 1. Okay, how many derivatives am I going to have to take? 3 derivatives, right? 3 derivatives to get 4 terms. All right, so what's f prime of x? Negative 1 minus x to the negative 2 times negative 1. Why, Dalton? Because of the chain rule. Excellent.
Oh,
So that's the same as that, right? Yeah, that's why we're doing it. Because had I just thrown that out there for you for a quiz question, you would have missed it. Because everybody would have forgotten the chain rule. Okay? So the first derivative at 0 is what? 1. And now I need to take the second derivative. And that second derivative is negative 2 times 1 minus x to the negative 3 times negative 1. So I'll just make it positive. So what's the second derivative at 0? 2. All right, I need the third derivative. And the third derivative is negative 6 times 1 minus x to the negative 4 times negative 1. And now I need the third derivative evaluated at 0. And what's that equal? 6. So can I now write that? Yes, I can. What's it come out to be? So 1 over 1 minus x is approximately equal to, right? This is how I need to represent it. What is it? 1 plus 1x, right? Plus 2x squared over 2 factorial plus 6x cubed over 3 factorial. Yeah, and so what are the coefficients going to do every time? Yep, so 1 over 1 minus x is approximately equal to 1 plus x squared plus x cubed, and so on. And what's my general term going to be?
X to the n. Well, n from 0 to
From n equals 0 to infinity of
x.
x to the n power. Okay, so I want you to go back and I want you to study this a little bit. I want you to look at this function and I want you to look at that. And I want you to tell me what kind of series that is. At the original function and at its general term. It is, Ted. It is geometric. What makes that geometric?
Because it's a constant.
Because it is a ratio being raised to the nth power. Now it's only going to converge if x is where?
Less than.
Between -1 to 1.
Oh, yeah.
Right? Because r can be plus or minus, right? The absolute value of r has to be less than 1 in order for a geometric to converge, okay? So this is geometric, all right? You come out and you get x to the n. So I want you to go back up to this 1 over 1 minus x. What is that? What does that represent? If this is the geometric series,
Is that the sum?
that is the sum. That's the sum of the geometric series, right? It's the sum of the geometric series, where a sub 1 is, what's a sub 1? 1. And r is x. So can you think of an easier way to write that function as a series?
A squared.
As a series. In other words, how can I want to write this as a series, but instead of going through this whole big long process, what's the only thing I have to do? Okay, so recognize that's a sum of a geometric where the first term is 1 and the ratio is x. And when you have a geometric series, how do you get from term to term? You multiply by the common ratio, right? So what's the first term? 1 plus, how do I get the second term? I multiply by x. 1 times x is x. How do I get the next term? I multiply x by x to give me x squared. How do I get the next term? Multiply by x. What have I just gotten? That same answer with a lot less work, right? With a lot less work. You wouldn't have missed this, right? This chain rule of -1, okay? So you can get that a lot easier. What's the sum? Same thing, right? X to the n.
Cam was wondering if she could borrow your wooden cross-section.
Yes. Yes, you can. Give me 1 second. Okay. So you do this one. Is everybody good there with what we did? You know what? This is going to be the same instructions, you guys. I should have done this. If you'll go here, in your example, I'll say write the first four terms in the general term of the Taylor's series expansion of f of x about x equals 0. And then I'm going to make number 1 be f of x is equal to 1 over 1 minus x. So I don't have to write all those instructions over and over again. Does that make sense?
Would you just have to say the first four non-zero terms?
Or no,
Or is that not?
a sub 1 over 1 minus r.
Okay, same set of instructions. Write the first four terms of that function.
We can use our newfound knowledge, right?
I hope that you do use your newfound knowledge. I have this one.
Right.
I like it like that. You all have a preference? Come on. What's the plural form of series?
What?
What's a plural form of series?
The series.
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 Reduce it. Look at the series and look at.
Okay, so you come to this problem and you look at it and you say to yourself, that looks a whole lot like a geometric series, right? Or the sum of a geometric series. Okay? So I know that the sum is equal to a sub 1 over 1 minus r. So in this particular case, a sub 1 is 1, r is x squared. And now I can take this function and I can write a Taylor series for it. And what will my first term be? 1 plus x squared plus, right, plus,
X6 or 3.
right, and so on. Okay, and you don't have to put that step in. You can go ahead and just go directly to it. Say again?
Isn't it kind of like substitution?
Uh-huh. Yep. It's just that we're manipulating the geometric form of it. Yeah. So then what does this become?
N equals 0.
Yep. Sum from n equals 0 to infinity of x to the 2n, right? Okay, same instructions. How about this one? Okay, so when you look at that, I don't know, you might not see that right away as being geometric, so you might start with taking the derivatives over and over again. And, you know, I don't know. I don't know if you'll see it right away in this particular one. But what do I need to do to get it to look like the form I need it in? I need to pull out a 4, right? And if I pull out a 4, what's that going to give me? 1 plus x over 4, And then if the 4 is in the bottom, that's the same as moving it to the top, right? And making the numerator 1/4. And then what do I need to do now?
Multiply. You have to multiply by this negative or just oh.
Can I do that?
There you go.
Right? Minus a negative is a positive. Okay, so now what's a sub 1? 1/4. What's r?
Negative x over 4.
Negative x over 4. So 1 over 4 plus x. What's the first term? 1/4. And then what am I supposed to do with that 1/4 each time? I'm just supposed to multiply it by the ratio, right? Right? And however you want to do that. It doesn't have to look exactly like mine.
Like a numerator rate.
Yeah, and so the reason that I did mine like this was just so that I could keep it in that same form. I could just do 1/4 times negative x over 4 to the n power.
So you kept the x, negative x fourth the same, and then you applied the n to the 1/4?
Well, it's 1/4 times that. Like there's, because see the 1/4 is in every single one of them.
Okay, I was, so it's the one, so you're multiplying each one by the ratio.
Correct.
And
So
then-
like here's what I did. I had my 1/4, right? And then my next term would be 1/4 times the ratio,
Okay.
right? And then the next term would be the previous term, which was negative x over 16 times the ratio,
Okay.
right? And then the next term would be the previous term, which was x squared over 64 times the ratio, okay? And again, I don't know, you might not like that. You might like to write yours a different way. Okay, so that is power series. And you're gonna have, I'm gonna hand you this homework sheet. It's got answers on the back, and we're doing 1 through 6 on here. And there are 2 where you omit, and it's written on there. So this is homework 9.9 worksheet 1 through 6.